This is SOSF. Man, what a crazy time to be alive. Seriously. Just when you think you've seen it all, you read something that just completely blows your mind. We talk about AI all the time on this channel. We talk about it writing essays, making pictures, all this weird, creative stuff. And we talk about the scary stuff, the Terminator-level weirdness. But there's this other side to it. This practical side, that is moving so fast, and it's about to change. Maybe everything. And I'm talking about our bodies. I'm talking about our health. We all know someone, right? Someone who's had to deal with cancer. It's this terrifying thing. It's this monster that, it just sucks. It's this medieval process. We find a lump, and the solution is to poison the whole body with chemotherapy, or blast it with radiation, or just cut it out. It's brutal. And for women, especially with breast cancer, it's a whole other level of brutal. So, check this out. I was reading this story. There's this woman, Brooke Davis, 40 years old, mom, from Iowa, and she gets the news. Breast cancer. It's the worst day of her life, and she's looking at her options, and the main option they're giving her is a mastectomy. Which is, they remove the entire breast. And look, you do what you gotta do to survive, 100%. But you can't tell me that's not a huge psychological blow. It's disfiguring. It's something that changes how you see yourself, how you feel in the world, forever. It's heavy. But her doctors, they had this new option for her. Something new. They said, what if we could build a perfect 3D model of you, of the tumor, of your breast, of everything, and use that to do a different kind of surgery? A breast-conserving surgery. They call it a lumpectomy, where they just take the tumor and a little bit of tissue around it. Now, lumpectomies aren't new, but the way they're doing them, this is the game changer. Think about how this stuff used to work, and how it still works in most places. The surgeon gets these 2D images, right? These black and white slices from an MRI or a mammogram. And they have to look at these slices, and mentally, in their head, build a 3D model of where this thing is. It's like trying to build a ship in a bottle while looking at blueprints for a different ship. It's an art. It's not a science. It's all about the surgeon's experience, their feel. And because it's so uncertain, they've got to take a big margin of healthy tissue, just to be safe. And even then, get this, a huge number of women who get this surgery have to go back for a second surgery. A re-excision, they call it. Can you imagine that? You go through all that. The fear, the surgery, the recovery. And the doctor comes in and says, damn. We looked at the tissue we took out, and the margins weren't clean. There were cancer cells right at the edge. We gotta go back in. It's heartbreaking. It's brutal. And it happens all the time. So, back to Brooke. Her doctors are using this new technology. It's from this company. I think it's called Symbiosis. And what they do is, they take all those 2D MRI scans, and they feed them into a powerful AI. And this AI, it doesn't just show them a 3D picture. It builds a one-to-one, perfect, 3D digital replica of her breast. It's like Google Earth for her tumor. The surgeon can put this thing on a big screen. They can spin it around. They can zoom in. They can fly through it. They can see exactly where the tumor is, not just up and down, left and right, but the depth. They can see the veins, in red. They can see the chest wall. They can see the skin. They can see the tumor, in blue, floating in there. And they get data. The computer tells them, the tumor volume is exactly this many cubic centimeters. It is exactly 1.4 centimeters from the chest wall. It is exactly 2.1 centimeters from the nipple. The surgeon knows everything before they ever pick up a scalpel. But here's the wildest part. This is the part that got me. When you get an MRI, how are you lying? You're lying face down, right? They put you in this tube, you're on your stomach. But when you have surgery, you're on your back. Now, breast tissue. It's soft. It moves. Gravity is a thing. The tumor is not in the same place when you're on your back as when you're on your front. So the map is wrong the second you get on the operating table. This is where the AI gets really smart. They call it spatial biophysics, which is just a fancy way of saying the AI knows physics. It simulates the effect of gravity. It models the skin elasticity. It takes the face-down MRI map and it recalculates it. It shows the surgeon exactly where the tumor will be, in real time, when the patient is lying on their back, on the table. It's a surgical GPS, and you need some serious horsepower to run this. This isn't running on your laptop. This stuff is being powered by these monster processing units from NVIDIA. We're talking A100 Tensor Core GPUs. This is the kind of high-level, heavy-duty iron that they use to train these giant language models or to render the most insane graphics in a video game. It's a beast of a machine, and it's being used to create this perfect, digital map of a human body. So, what happened to Brooke? The surgeons used this 3D map. They went in. They knew exactly where to cut. They didn't have to guess. They didn't have to take this huge chunk of tissue just in case. They went in, with this new level of precision, and they took just the tumor and the tiny clean margin they needed. The surgery was a success. She didn't need a mastectomy. She got to keep her breast. And when they asked her about it, she said this thing that really sticks with you. She said she got to emerge from this whole nightmare without any of that disfigurement. It preserved her confidence. That's huge, man. We get so caught up in the clinical metrics and the survival rates. And that's number one, of course. You gotta survive. But there's a life to be lived after you survive. And going through life feeling whole, feeling like yourself. That's not a small thing. That's everything. And think about her daughters. The report I was reading made this point. Her daughters, they now have a higher risk, right? It's genetic. And for a lot of people in that spot, the fear of the treatment, the fear of mastectomy, is so bad that they avoid getting screened. They don't want to know. But her daughters? They saw their mom beat this thing, and come out the other side. Whole. That's not just an emotional benefit. That's a public health benefit. That's hope. That's a whole new world. It's incredible. And you're thinking, wow, a 3D map. That's the future. No, that's not the future. That's the beginning. That's like the first time someone used a map in a car. The real crazy stuff. The mind-bending science fiction stuff they're working on. Is this thing called a medical digital twin? What they used on Brooke, that was a digital anatomical replica. It's a static map. It's amazing, but it's a snapshot in time. A true digital twin, man. A true digital twin is a simulation. It's a version of you. A copy of you. A ghost in the machine you. And it lives inside a supercomputer. It's not just a picture. It's a dynamic, computational model of your body. It starts with your entire genome, your DNA. Then they add your blood work, your lab results, your medical history. They feed it all your imaging scans. They feed it data from your watch, your fitness tracker, how you sleep, what your heart rate is, everything. And this digital twin, it's not static. It's alive. It's linked to you. It gets updated, in real time, with all this new data. It learns. It adapts. It ages. Virtually. Right alongside you. This is not a what-if idea from a stoner movie. This is what they're building. NASA did this first. Back in the 60s, man, they built digital twins of the Apollo shuttles. So when something went wrong in space, they could run simulations on the twin back on Earth to figure out how to fix it. Okay, let's try this. Oh, that blew up. Don't do that. Now, they're doing it for people. So, why? Why build this crazy virtual you? Here's why. Let's say you get diagnosed with something. Cancer. Whatever. The doctor sits down. Not with you, but with your digital twin. And before they give you the real, physical you, one single drop of chemotherapy, one pill, one anything, they give it to your twin. They run a simulation. Okay, let's try the standard chemo cocktail on Virtual Joe. And the computer runs it. It models how your specific tumor, with its specific genetic markers, will react. And the computer says, 50-50 shot. And look, his virtual kidneys are taking a beating. He's going to be incredibly sick. Probably won't work. The doctor goes, okay, scratch that. What about this new immunotherapy drug? They run it on the twin. Boom. Look at that. The tumor is shrinking 95%. And minimal side effects. That's the one. They can run dozens of virtual experiments on your twin to find the perfect therapeutic strategy. The one with the highest chance of success and the lowest risk of side effects. All before they ever touch you. It's personalized medicine. Not, oh, you're this type of person, so you get this type of drug. No, it's hyper-personalized. It's medicine for you. Joe Smith. And only you. It's staggering to think about, but think bigger. Hey, you know I'm going to say that. Think bigger. What's the most broken, expensive, and slow part of medicine? It's how we get new drugs, right? Clinical trials. You have a new drug. You think it might cure, I don't know, pancreatic cancer. You have to spend years and billions of dollars. You have to recruit thousands of people. You give half of them the real drug, and half of them a placebo, a sugar pill. And you wait, and you watch, and it takes 10 years. And after all that, something like 90% of them fail. The whole thing is a wash. Billions of dollars. Gone. What if you don't need to recruit 10,000 real people? What if you just build 10,000 digital twins? You create an in silico cohort, a virtual clinical trial. You've got digital twins with all kinds of different genetics, different ages, different backgrounds, and you give them all your new virtual drug. And instead of taking 10 years, you get the results in an afternoon. You can test 1,000 different drugs in a week. You can find the ones that work, find the ones that are dangerous, and throw those out before they ever get near a human being. They're already proving this can work. There's this one technology. I think it's called Farsight Twin. They used it to recreate past clinical trials. They built the twins, gave them the drugs, and the simulation perfectly matched what happened in the real world years earlier. It's validated. This is a disruptive bomb. This ends the entire clinical trial industry as we know it. It saves trillions of dollars. It brings life-saving drugs to market in a fraction of the time. This is the part that's hard to even wrap your head around. The scale of it. And this whole thing. The surgical map. The digital twin. It's not happening in a vacuum. It's just one part of this AI wave that's hitting every single step of cancer care. It's already here. You just don't see it. Like mammograms. You go in for a screening. A radiologist, a human, looks at it. They're looking for these tiny little spots or shadows. It's an incredibly hard job. They're tired. They've looked at 100 of these things today. They might miss something. So now, they've built AIs to be a second reader. It's like having the world's most diligent, obsessive, superpowered radiologist, who never gets tired, never blinks, and has seen 10 million mammograms. The human reads it, and then the AI reads it. And the data is just insane. They did this massive study, the AI Stream study. They found that radiologists using this AI copilot had a significantly higher cancer detection rate. Another huge, real-world study. The Priam trial. It was published in Nature. Man, this is legit. They found that the AI-supported team detected 17.6% more cancers than the standard 2-human reader team. Think about that. 17.6%. That's not a rounding error. Those are lives. Those are people who got their cancer caught early, when it's curable, instead of a year later when it's too late. And it doesn't stop there. Okay, so the mammogram finds a spot. What's next? A biopsy. They take a tiny piece of the tissue. They put it on a glass slide. And a pathologist looks at it under a microscope. This is another human, trying to see. Okay, is it cancer? How aggressive is it? What kind is it? Now, AI is doing that too. They scan the whole slide, create this massive digital image, and the AI analyzes it. It can detect tiny clusters of cancer cells in a lymph node that a human eye might just scan right over. It can count the mitotic rate, how fast the cells are dividing, to grade how aggressive the cancer is. It's more objective. It's more consistent. They're even training AIs to look at the patterns in the tissue, just the shape of the cells, and predict whether that patient will respond to chemotherapy. Stuff that right now, we need expensive genomic tests to figure out. The AI is just seeing it in the image. And then, you get to treatment. Radiation. You know how radiation works? They have to blast the tumor with this beam. But they cannot hit your heart. They cannot hit your lungs. So, a human, a radiation oncologist, has to sit there for hours, with a mouse, drawing on your CT scan, literally drawing the contours. This is the tumor. This is the heart. Don't hit this. This is the lung. Don't hit this. It's tedious. It's time-consuming. Now, an AI does it. In minutes. It does the auto-contouring, perfectly. It frees up the doctor to, be a doctor. And it's more consistent. And the AI can then design the perfect treatment plan. Okay, we'll hit it with a beam from this angle, and this angle, and this angle, and we'll miss all the healthy stuff. It's a multi-front assault, from detection, to diagnosis, to surgery, to treatment. It's everywhere. Now, at this point, you gotta be thinking, this all sounds amazing. But, what's the catch? And, there's a huge catch. There are a few of them. This is the but part of the conversation. First, you got the government, the FDA. How do you regulate this stuff? This isn't a pill. A pill is a pill. It's stable. You test it, you approve it, it's done. This AI software, it changes. It learns. The version they approve today might get an update tomorrow and be totally different. So the FDA is scrambling. They're coming up with this new idea. They're calling it a total product lifecycle. It's not a one-time approval. It's like the government is subscribing to the AI. The company has to constantly monitor its performance, constantly report on it. It's software as a service medicine. It's a whole new world for them. But the real problem, the one that really keeps people up at night, is the black box. A lot of these deep learning models, they're so complex that even the engineers who built them don't really know how they work. You ask the AI, why do you think that shadow on the mammogram is cancer? And the AI just says, because, 98.7% probability. You ask, yeah, but why? And it can't tell you. It just knows. It has seen patterns in 10 million images that no human brain can comprehend. And doctors are not comfortable with that. They're scientists. You gotta show your work. You can't just say the computer told me to when you're about to cut someone open or pump them full of poison. So there's this huge push for what they call explainable AI. XAI. They're building new models. There's one out of Duke University. That doesn't just flag a spot. It highlights the features of the image that led to its conclusion. It shows the radiologist why it's suspicious. That's the only way you build trust. But here's the scariest one. This is the monster under the bed. Algorithmic bias. These AIs, they're not smart. They're just trained. They learn from the data we give them. So, what data are we giving them? What if an AI that detects skin cancer is only trained on images of light skin? What happens when a person with dark skin comes in? The AI might completely miss it. It's blind to it. What if a mammogram AI is trained 90% on data from one ethnic group? Its performance for other groups could be terrible. This is not a small problem. This is a catastrophic risk. You could accidentally, without meaning to, build a system that hardcodes, that amplifies existing health inequalities, a system that literally gives worse care to certain groups of people. It's a nightmare. It's a legal landmine. Can you imagine the lawsuits? Your hospital deployed a biased AI that misdiagnosed an entire community. It's terrifying. So the FDA is screaming about this. They're telling developers, you must prove how you addressed bias. You must show us your training data was diverse and representative. And then there's the last question. If the AI does get it wrong, who's to blame? Who gets sued? The doctor, who listened to the AI? The hospital, who bought the software? Or the tech company in Silicon Valley that wrote the code? There is no legal precedent for this. Nobody knows the answer. So, man, it's a lot. We're standing on the edge of this revolution. On the one hand, we've got this incredible, life-saving promise. The end of one-size-fits-all medicine. Precise, GPS-guided surgeries like Brooke Davis got. AI copilots finding cancer years earlier than we ever could. And then, this other thing. This ultimate goal. The life course digital twin. Think about that. A virtual copy of you, born when you are, built from your DNA. And it lives its life in a computer, 5 years ahead of you, simulating your future. It's not even about treating cancer. It's about preventing it. Your digital twin, in the year 2035, develops virtual heart disease. And so, in 2030, your doctor calls you. Hey Joe, your twin just had a heart attack. We ran the simulation. If you don't change your diet, right now, you're toast in 5 years. But, we also ran a simulation where you cut out sugar and started walking 30 minutes a day. And in that one, your twin is running a marathon at 80. It's proactive, predictive medicine. It's the biggest paradigm shift, maybe ever. But to get there, we have to climb this mountain of insane ethical problems. The bias, the black box, the privacy. Who owns your digital twin? Your insurance company? Your employer? The government? It's just wild. It's all happening right now. The National Cancer Institute. These aren't crazy people. They put out a statement. They said the question is not if, but when, how, and why. This is coming. This is the new world. It just makes you stop and think. Here's a crazy thought. If you had one, a perfect, digital twin of you. A virtual copy that knew your biology, your genetics, your future risks, better than you do. And that twin, that machine, told you, with 100% certainty, that the one thing in life you love doing the most, the one thing that gives you the most joy, was guaranteed to be the thing that kills you in 5 years. Would you stop? Or would you tell the machine to go screw itself, and live your life? See you next time.